Hello, my name is Kylie Hession, and this is my TED Talk for Celebration of Writing. Have you ever lost someone close to you from a fatal disease or a genetic disorder? There are many treatments that are available today for all different kinds of conditions, but many are unsuccessful in curing patients. What if there was some way to treat disorders like cardiovascular disease, genetic defects, or even help the regrowth of a spinal cord that had been damaged? Well, there have been recent studies on the works of gene therapy. Gene therapy is the implanting of new genetic material into cells in order to prevent the symptoms of disease. With the new studies being done on how to edit genetic material, scientists in the future could possibly eliminate fatal disease after children are born. There are many studies that have already been conducted to test the validity of this idea. The studies have given a lot of information that has fueled the research for the perfect mode to use to deliver these genes. Throughout the years, scientists have discovered that viral vectors are the perfect mode of delivery to implement their theory of gene therapy. Now, this might sound weird, but remember the whole goal of this theory is to infect all of the cells in a patient in order to create a new genome. To clarify, viral vectors are viruses that the biologists have manipulated by removing the infectious genes and have inserted a new gene set into them in order to correct the defective genes in the patient. With the manipulations performed on these viruses, they are able to replicate within the cells of the patient to diminish the symptoms of the condition or disorder, which could be fatal. Now I want to look into the different types of viral vectors and the advantages and disadvantages of all the different kinds. Throughout the last 20 years, the researchers have discovered the fact that adeno-associated viral vectors are the #1 candidates for gene therapy. There are many other kinds of viral vectors, but adeno-associated viruses have the most benefits and compatibility to use for the manipulation and gene delivery in patients. Some of these benefits include their ability to infect many different types of cells. Some other advantages to using adeno-associated viruses for gene therapy include low to non-existent pathogenicity, which means that the pathogens in the virus are very low and that they do not infect the body as much as other viruses that could be used. And another advantage is the ability to infect dividing and non-dividing cells. So this means that it can target all different types of cells in the body, and that's very, very good for the goal of the experiment, which is to help infect all the cells in the body so that the human's genome is new and doesn't have the symptoms of disease. And after the genes are injected into the body, they have a prolonged persistent gene expression, which means that they don't die fast and that using these genes for the gene therapy is very well. An example of an adeno-associated virus that has been really successful in trials for gene therapy is the vaccinia virus. And this virus was originally included in the smallpox eradication campaign, which means that it was used as a smallpox vaccine and that it was a cure for smallpox. And the studies that have been conducted for this is with cancer patients, because a lot of the traditional cancer treatments are really damaging to the body. And so right now they have tumor resection for cancer treatment, and that is a bad idea because there's a possibility of the tumor growing back because the resection and the surgery didn't remove all of the cells. And then there's also chemotherapy and radiation, and they're not ideal because they're not efficient at targeting specific cells in the body. So when like a cancer patient has a tumor, when they use chemotherapy and radiation, it affects all, like even the healthy cells around. So this strain is a really successful strain in studies because it can hold a lot more DNA than any of the other viruses that they've tried. And this is great because that's the whole disadvantage with gene therapy and using viral vectors, because usually they can't include a lot of genetic material because they're small little genomes. So the VAC-V virus, as it's called, is a huge success right now. They're doing more trials and trying to figure out ways to include this in gene therapy. So there's some manipulations of the VAC-V virus that have shown to be very successful in gene therapy, and that's they have immunoregulatory factors, which means that they target the cells in the immune system. So although that there has been a lot of success in using viral vectors for gene therapy, there are other treatments that are in question right now. They're doing trials for different kinds of treatments. And the main concerns with viral vectors is that they can lead to inflammatory immune responses, and this is when they target the healthy cells and it makes all the other cells inflamed because they didn't need to be infected with the virus. And also they do not hold a big amount of genetic material, which is kind of a downer because you want to get the most amount of genetic material in the viruses that you possibly can. And so there's new treatments that are coming out in trials that have to do with poration, which is the penetration of the cell wall. And there's different types like electroporation, which is the use of an electric field, and this is a good method, as well as magnetoporation, which is the use of a magnetic field. Sonoporation is perforation by ultrasound. It's using an ultrasound probe. And optoporation is the use of a laser pulse to get into the cells to edit their genome. And this is a new way in the past few years that have come about to edit the genes and to make them able to be injected into the body to create a new genome for the patients. And there's a lot of studies that need to be done, so they're not really sure if it's successful in patients, but it's just a new way of using gene therapy instead of using vaccines. Degeneration is a devastating condition, and it causes a lot of pain or even paralysis, and so that's why it makes it a good candidate for gene therapy and all of the possibilities that it has to offer. And so a good thing about the spinal cord is that it already has the ability to regenerate itself. It just needs a little bit of provoking in order to do this, which is why gene therapy is a good treatment method for spinal cord degeneration. So some of the advantages for gene therapy for spinal cord regeneration include multiple different genes from one delivery method. So when you manipulate these genes, you can put multiple different genes that you need into one cell so it replicates in the body, and you can deliver it all in one go. So you can attack multiple different conditions with one delivery. And gene therapy has a lot of flexibility. You can change it any way you need to in order to treat the condition, and it is also localized to all different cell types. And this is good. So in conclusion, throughout all of my research, I've realized that gene therapy has a long way to go to become a FDA-approved treatment method, and it's going to take some time, but I think in the future when it is there have been full trials run and it's complete, I think it could be a new way to change the face of medicine, because you don't need to use the treatments or spend money on the treatments that we have now, which aren't even really effective. So it's an efficient way to do this. So once we figure it all out, it's going to be a great way to tackle life-threatening diseases, genetic issues, and different ways that people are dying around the world. So it could really help out the world to create a great way to live and not die from different conditions. Thank you for coming to my TED Talk.